Hello, and today we're going to be covering a new topic, negation. Negation, basically, here's the basic idea. So, negation, we can use it as something called an additive inverse. And basically, the additive inverse is the number that will add to another number to get 0. So, if we had 2, what will we add to 2 to get 0? Well, we would subtract 2, which is the same thing as adding -2. So -2 is the negation of 2. So now that we know what negation is, let's try to figure out what the negation of, say, 5 is. What can we add to 5 to get 0? Well, using the same logic as we used here, 5 plus -5 is 0. So -5 is the negation of 5. Now what's the negation of -3? What can we add to -3 to get 0? Well, addition is commutative, we know that. So let's just put an unknown here, question mark, and we know that's 0. Now let's flip around the question mark and the 3, and we get question mark minus 3 equals 0. So it's 3. So the negation, even though it sounds like it's referring to negative numbers, is really just the opposite. It can still be positive, as we saw here. Alright, so now once this clears, we'll take a look at some more problems. Alright, so now let's figure out why the negation of -3 is positive. Well, we're taking the negation of -3, so we'll write it something like this. And this is going to be positive. Now, we can prove this. So if you're still not convinced, here's a proof that a negation can be positive. So let's say we have, for any number x, we have x plus -x plus negative of -x. So x plus the negation of x plus the negation of the negation of x. So we know addition is associative. So if we start by adding the first two, these two are additive inverses. 0 plus the negation of the negation of x, which is just the negation of the negation of x. Now, if we choose to add the negation of x and the negation of x first, this is the negation of this. And we know that adding a number to its negation is 0. So we have x plus 0 equals x. Now we know that the x, these two are equal because we just flipped around the numbers. It'll be the same answer anyhow. So x equals minus x. So that's a pretty cool proof. Alright, so now let's take a look at multiplication of negations. So we can multiply positive numbers. 3 times 3 is 9. 5 times 4 is 20. They made you recite your multiplication tables and all that. But what's negative 2 times 4? Let's see. Actually, negative 1 times 4. What's negative 1 times 4? Well, let's recite our times 4 table. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. So you can see here, it goes down 4 every time a number goes down 4. So for example, 3 times 4 is 12. Decrease this by 1. 2 times 4 is 8. This decreases by 4. Decreases by 4. And they're directly proportional. So, turn this to 0, decreases by 4. Negative 1, decreases by 4. So this is negative 4. So, it looks like multiplying a number by negative 1 is the negation. But, again, let's prove it. So, let's say negative 1 times x plus x equals 0. Now, we can substitute x for 1 times x. So we have negative 1 times x plus 1 times x equals 0. And that's 0 times x, which is 0. So that's the proof. It's true. Alright. So, a couple more things to concern multiplication. So, let's say we have negative 2 times 3, and we need to prove that that is equal to negative 2 times 3. How are we going to do this? Let's try multiplying by negative 1. So we have negative 2 times 3 equals negative 1 times 2 times 3. And we know negation is the same as multiplying by negative 1. So we can do that. Then we can use the associative property, negative 1 times 2 times 3, which is negative 2 times 3. So, yeah. And let's use this to figure out something else. If we have negative 2 times negative 3, is that equal to 2 times 3? Let's see. Well, negative 2 times negative 3 can be written as negative 2 times negative 3. Same thing. Alright, so we're multiplying by negation. So we can take this out right here. So it's negative 2 times 3. And that is negation of negation. That's a positive. That's 2 times 3. Alright, so sorry if that was a little confusing, but you can explore more of negation on your own. And yeah, thanks for watching.